Hello, welcome to this lesson. In this video, we are going to solve this question I have on your screen. The question says three cables are used to tether a balloon as shown. Knowing that the balloon exerts an 800 Newton vertical force on the ring at A, determine the tension in each cable assuming equilibrium. So let's look at how you are going to solve this question. Okay, so to solve this question, you are going to apply the three force equations, okay, for equilibrium because what we have here is a 3D system. So we are going to have some of the forces in the x-axis direction to be equal to 0, and then some of the forces in the y-axis direction to be equal to 0, and also some of the forces in the z-axis direction to be equal to 0. Okay, so I'll define the directions for the axis, okay? Let me do that here. So we consider this direction to be the positive y, this will be positive z, and then this should be positive x, okay? So this should be plus y, this should be plus x, and then this should be plus z. Okay, so for this figure that I have here, we are actually supposed to draw a free body diagram, okay? But I have a limited space, so I won't draw that, but you will have to draw it in your solution. Okay, so what will happen is that the balloon is exerting an 800 Newton force, okay, an 800 Newton force in the upward direction, okay, which I'll indicate here. Okay, so what will happen is that the balloon is trying to pull up, but the tensions in the cables are pulling it down. Okay, so what you have to do is to find the tensions that will cause the system to be in a equilibrium. Okay, because the balloon is pulling up, and then the tensions in the cables are holding it in position, making the system to be in an equilibrium position. So you have to find the tension in the cables. Okay, that's what you have to do. So for the tension in cable AB, I'll name it as TAB, and then that of in cable AD, I'll name it as TAD, and then for cable AC, that'll be TAC. Okay, so you have to find the tension in all these three cables. But how do we do this? Okay, so to do this, we have to find the component of each of the tension forces. Okay, and to do this, you are going to first of all find the direction vector of each of the forces, and then after finding the direction vector, you multiply the direction vector by the magnitude of the forces. So let's look at what I mean by that. So first of all, I'll consider the tension in cable AB, okay, in cable AB. So to find the direction vector, we will first of all have to find the position vector, okay. So how do you find the position vector? So assuming we are moving from point A to B, we are going to move in this direction, okay, in the y-axis direction, then we take this direction in the x-axis direction to get to point B. So let's write down the values we have from there. So we are going to move minus 4.2 meters in the x-axis direction, right? And then minus 5.6 in the y-axis direction. So that will be the position vector. So you will now have to find the magnitude of this position vector, okay? So we are going to have 4.2 squared plus 5.6 squared, okay? When I do this, you're going to have the magnitude to be 7. So now let's find the direction vector. The direction vector will be minus 4.2 over 7i, okay, minus 5.6 over 7j, okay. This will be the direction vector. So to find the vector for the tension force in cable AB, we're going to have TAB, okay, which is a vector to be minus 4.2, okay, minus 4.2 on 7, okay, multiplying what? TAB, okay, and then vector I, okay, minus 5.6 on 7, okay, multiplying TAB, okay, vector J, okay. So those are the components of the tension in cable AB, okay. So let's take note of that. So I'm going to do the same for cable AC and then AD. So let's go ahead. Okay, so if you're not seeing this figure clearly, then you have to increase the quality of the video, okay, so that you can see the values for, because this figure is not really clear here. Okay, so now let's focus on TAC. TAC. So for TAC also, you will have to find the position vector. Okay, so let's look at that. So for that one, so we are moving from point A to point C. Okay, so I'll move in this direction. Okay, then I'll move in this direction. Then I'll later move in this direction. Then from there, you'll see that you are still not at point C. Okay, you have to move a little distance in this direction here. Okay, so now let's find the position vector. Okay, so for the position vector for the x direction, you see that we moved this distance in the x, right? And then later moved another small distance in the x, right? So the actual distance traveled in the x will be this 2.4 meters. So we are going to have 2.4 I, right? And then it is in the positive x axis direction. And then we are going to have minus 5.6 j, which is in the negative y axis direction, and then plus 4.2k, which is in the positive z axis direction. So now let's find the magnitude of this. So we're going to have 2.4 squared, right, plus 5.6 squared, okay, plus 4.2 squared. This will give us a value of 7.4, okay. So now finding the direction vector, you have to divide the position vector by the magnitude, okay. So we are still on TAC. Okay, so TAC continued. Okay, so we are going to have 2.4 divided by 7.4 I, right, minus 5.6 divided by 7.4 j, okay, plus 4.2, okay, divided by 7.4 k, okay. So to get the actual vector, it will be vector TAC, which has the component of the forces. We are going to have 2.4 over 7.4 TAC multiplying vector I, okay, minus 5.6 on 7.4, okay, multiplying TAC times vector J, okay, and then I'm going to have plus 4.2 on 7.4 multiplying TAC times what vector K. Okay, so those are the components of the tension in cable AC. Okay, let's take note of that also. Okay, so you're going to do same for cable AD. Okay, let's take note of that. So for TAD also, let's find the position vector. Okay, let's find the position vector. Okay, so moving from point A to D, okay, moving from point A to D, starting from point A, okay, we move in this direction here, and then we move in this direction here. Okay, all right. So for the position vector, okay, we didn't move in the x direction, so that will be 0I. And then for the y direction, I'm going to have minus 5.6j. And then for the z direction, I'm going to have minus 3.3k. So let's find the magnitude of this. Okay, that will be the square root of 5.6 squared plus 3.3 squared. That will give us a value of 6.5. So now let's find the direction vector. We're going to have minus 5.6 divided by 6.5 j, okay, minus 3.3 divided by 6.5k. So now let's find the direction vector. Sorry, let's find the component. This is the direction vector, okay. So now let's find the vector force, which would be TAD. TAD, okay. So for that one, you're going to multiply the direction vector by the magnitude of the force. You're going to have minus 5.6 on 6.5 TAD, okay, multiplying vector J, minus 3.3 on 6.5 TAD multiplying vector K. So this is what you have. So those are the components of the various tension in the cables. Okay. So now that you know the components of the tension in the cables, you have to apply the equilibrium equations and then solve for the unknown values. So let's go ahead and then look at that. Okay, so let's consider the first equation. We have some of the forces in the x-axis direction to be equal to 0, right? So for that one, for the for TAB, okay, the x component is minus 4.2, right, on 7 multiplying TAB, okay, and then for TAC, the x component is 2.4 on 7.4 TAC, right? And then TAD doesn't have an S component, so we are equating this to 0. Okay, all right. So now let's consider some of the forces in the y-axis direction also. Okay, so for that one, for TAB, you have the y component to be minus 5.6 on 7 TAB, right? TAB, and then for TAC, you have the component to be minus 5.6 on 7.4 TAC, right? And then for TAD, we have minus 5.6 on 6.5 TAD, then plus the force that the balloon was exerting the positive x-axis, which will be plus 800, and this should be equal to 0. Okay, let me write the 800 again, plus 800, which is equal to 0. So this will be our equation 2. So now let's consider some of the forces in the z-axis direction. So for that one, for TAB doesn't have a z component, okay, so that will be 0. And then for TAC, we have the z component to be 4.2 on 7.4 TAC. And then for TAD, we have minus 3.3 on 6.5 TAD. So this should be equal to 0. So then we have three equations. This is equation 1, this is equation 2, and then this is equation 3. Okay, so you will have to solve these three equations simultaneously to get the value of the unknowns. So I'm going to do this using a calculator. Okay, so let's look at how I'm going to do it. Okay, so let's go ahead and then use the calculator to solve this example here. Okay, so let's look at that. Okay, so to use the calculator, first of all, you have to press on mode. Okay, then choose the fifth option, which is equations, and then you have three equations with three unknowns, so you have to go for the second one. Okay, so let's look at that. So you go for the second option, which is 2. Okay, so now what you have to do is to enter values. Okay, so the first variable is TAB, the second is TAC, and then the third is what, TAD. So for the first equation, the coefficient of TAB is minus 4.2, right, on 7. Okay, and then the next one, which is the coefficient of TAC, will be 2.4, right? So that will be 2.4 divided by 7.4. Okay, and then for TAD, that will be 0, and then on the right hand side also you're going to have 0. Okay, so now let's move on to the second equation. The coefficient of TAB will be minus 5.6 on 7. Okay, and then that of TAC will be minus 5.6 on 7.4. Okay, and then for TAD, that will be minus 5.6, okay, on 6.5. Okay, and then on the right hand side, we'll have to take the 800 to the right hand side, so I'm going to have minus 800. Okay, so now let's look at the last equation. So for the last equation, the coefficient of TAB is 0, okay, and then that of TAC is 4.2 on 7.4, okay, and then that of TAD is minus 3.3, okay, on 6.5, okay, and then on the right hand side we are going to have 0. So now let's look at what you have. Okay, so for TAB, okay, you are going to have 200.913 newton, okay, and then for TAC you are going to have 371.689 newton, and then for TAD you are going to have 415.525 newton. So those are the values of the unknowns. Okay, you can choose to solve it manually also if you don't want to use the calculator. So now let's write down the values we have. Okay, so for TAB, okay, we got 200.913 newtons, okay, and then for TAC, okay, we got 371.689 newtons, and then for TAD, okay, we got 415.525 newtons. So those are the values of the tensions in the cables that will keep the system in equilibrium. Thank you very much for watching this video. If you find this video useful, please make sure you like the video and subscribe to the channel so that anytime I upload new videos, you will be notified. Thank you.